Hello, you absolute legends. My name is Don Kavanaugh. Let's describe the start, middle, finish of solvation in aqueous solutions. These three beakers are meant to be identical beakers, but at different points in time. At the start of time, we have a pure solution of water, H2O. I have kind of the wave up here to indicate that we're talking about liquid phase. And I've chosen the color blue, and I've explicitly just wrote out H2O, H2O. Now at the start, this is an ideal solution where molecules are moving and tumbling and colliding at fantastic rates. In the middle, we can introduce a molecule that will dissolve in aqueous solution. That could be a polar compound or most ionic compounds. The compound that we're going to pick right here is we're going to have NaCl. So NaCl, table salt. The formula NaCl is written up here for table salt, and the individual ions, sodium and chlorine, are written here. Now they are together in an ionic compound and at the surface interface of the water. In the middle of the process of solvation, as these ions become in contact with the water, they begin to be surrounded by water molecules. So our water molecules will begin to surround those different ions. Now, specifically, what I don't have drawn in here yet are electrons and charges. The water molecules begin interacting with the cation or the anion. And what happens to these ions when they begin the finish of total solvation? As those ions begin to drift into the solution, the chlorine ion will separate from the sodium ion. This is very interesting. This ionic compounds that solvate in water separate into their cations and anions. And they are individualized, shall we say, and surrounded by water molecules in what is called the solvation sphere or solvation shell. I cannot draw a sphere. And this two-dimensional plane, you have to imagine the sphere. Water's ability to solvate anions and cations is very unique and special for water. Water is a polar molecule, so it will readily dissolve ions in solution. Most ionic compounds dissolve in water. I hope this helps. Thank you.